As we move towards a future powered by clean energy, our electricity grids face a monumental challenge, handling an ever-growing demand while modernizing aging infrastructure. Traditional grids were designed for a centralized power source and a passive consumer base. But today's grids must adapt to a dynamic, distributed environment where customers are increasingly generating their own power from solar panels and participating in the energy marketplace with smart appliances and electric vehicles. This shift demands a smarter, more efficient solution, a transformation that is being driven by the adoption of smart meters and data analytics. In this new paradigm, every home and business becomes a prosumers, both consuming and producing energy. And at the heart of this transformation are smart meters, the digital eyes of the grid. As we delve into the topic, you'll discover how these meters are not just changing the way we measure energy, but are reshaping the entire energy landscape, making it more sustainable, efficient, and resilient. Welcome to our channel, your place for the latest tech reviews and concept renders. Welcome to our channel, and in today's video, we are here to discuss smart meters and data analytics, empowering grid efficiency. So let's get into the video without any further ado. The modern electrical grid is a marvel of engineering, a complex network that delivers power to millions of homes and businesses reliably. But like all intricate systems, it faces challenges, especially as we transition to cleaner energy sources and embrace more digital technology. Traditional analog meters, the devices we've long relied upon to measure energy consumption, were designed for a simpler time when the grid was less complex and customer needs were less demanding. However, in today's world, they fall short in several critical areas. First and foremost, the grid is under increasing strain due to the growing demand for energy. As economies grow, more people use electricity for lighting, heating, cooling, and an ever-expanding array of electronic devices. Additionally, the shift towards renewable energy sources, such as solar and wind, adds another layer of complexity. These sources are intermittent, meaning their output fluctuates based on weather conditions, requiring the grid to adapt and balance supply and demand constantly. Secondly, the aging infrastructure of many grids needs modernization. Decades-old equipment may not be equipped to handle the demands of the 21st century, making the grid vulnerable to outages and inefficiencies. Moreover, the lack of real-time visibility into grid operations makes it challenging to anticipate problems or respond swiftly when they arise. Furthermore, there's the challenge of integrating distributed energy resources, DERs, such as rooftop solar panels and battery storage systems into the grid. When everyone starts generating their own power, the grid's dynamics change significantly. It's no longer a one-way street where power flows from the provider to the consumer. It becomes a two-way street where prosumers can feed energy back into the grid. And finally, the issue of energy theft or inaccurate billing adds another dimension of concern. Traditional meters are vulnerable to tampering, leading to financial losses for utilities and unfair pricing for customers. Inaccurate readings can also cause billing errors, frustrating customers and complicating the utility's operations. This is where smart meters come in, offering a beacon of hope in these turbulent times. By replacing outdated analog meters, smart meters can address many of these challenges head-on. Let's take a look at how. Smart meters are the epitome of modern technology, replacing the outdated analog meters with digital prowess. These intelligent devices go beyond measuring energy consumption. They provide a wealth of information about voltage fluctuations, power outages, and other vital grid parameters. With the ability to communicate data in near real time, they allow utilities to monitor and control the grid more effectively than ever before. But what exactly sets smart meters apart? What makes them the ideal solution for the modern grid? Smart meters leverage advanced communication technologies such as cellular or Wi-Fi networks to transmit data to utilities. This capability enables utilities to gather information about energy consumption and grid performance on a continuous basis. No more waiting for scheduled meter readings or dealing with estimated bills. These meters provide accurate, up-to-date information, allowing consumers to track their energy usage and make informed decisions about their consumption patterns. Moreover, smart meters can detect and report power outages, voltage drops, and other anomalies immediately. This real-time visibility enables utilities to respond quickly to issues, minimizing downtime and improving the overall reliability of the grid. But the benefits don't end there. Smart meters lay the foundation for a more interactive and customer-centric approach to energy management. They enable consumers to access their energy usage data, analyze it, and adjust their habits accordingly. This increased transparency empowers consumers to become active participants in the energy market, reducing waste and optimizing their energy use. For instance, with insights provided by smart meters, consumers can determine the most cost-effective times to use energy-intensive appliances. They can also monitor their energy usage in real time, preventing energy waste and reducing their environmental footprint. This level of control and visibility is a significant leap forward in the energy sector, marking a shift from passive consumers to engaged energy citizens. In essence, smart meters are the eyes and ears of the modern grid, constantly observing, reporting, and adapting, making the grid smarter, more responsive, and more sustainable. Imagine a bustling city where traffic flows seamlessly, where accidents are immediately reported and emergency services are deployed efficiently. This isn't a scene from a sci-fi movie. It's a glimpse into the potential of a city powered by smart meters and data analytics. When it comes to leveraging the full potential of smart meters, data analytics plays a pivotal role. The wealth of data gathered by these meters is transformed into actionable insights, driving significant improvements in grid efficiency and reliability. Advanced analytics and machine learning algorithms are employed to sift through vast amounts of data, identifying trends, anomalies, and patterns. These analyses can reveal critical information about the grid's performance, such as overloaded circuits, aging infrastructure, and need of repair and fluctuating energy demands. For instance, data analytics can help identify customers who are heavy users of energy during peak hours. By understanding these usage patterns, utilities can implement programs to encourage these customers to shift their energy consumption to off-peak hours, reducing strain on the grid and decreasing the likelihood of blackouts during peak demand. Moreover, predictive analytics can forecast equipment failures before they occur. By analyzing historical data and real-time sensor readings, utilities can anticipate issues with transformers, circuit breakers, and other critical components, allowing for proactive maintenance and reducing the incidence of unexpected outages. Data analytics also plays a crucial role in managing distributed energy resources, such as rooftop solar panels and battery storage systems. As more prosumers join the grid, data analytics helps ensure a smooth integration of these resources, balancing supply and demand and maintaining grid stability. By analyzing data from millions of smart meters across the network, utilities gain a comprehensive understanding of energy consumption patterns, usage elasticity, voltage levels, and transformer loading. This deep insight enables evidence-based decision-making regarding infrastructure upgrades, resource allocation, and investment in new technologies. Furthermore, data analytics allows utilities to perform what-if simulations, testing various scenarios to assess the impact of extreme weather events, cyber attacks, or equipment failures on the grid stability. This proactive approach helps build a more robust, resilient grid capable of withstanding unforeseen challenges. In essence, data analytics transforms raw data into actionable intelligence, empowering utilities to enhance grid efficiency, reliability, and sustainability. It enables a more proactive, customer-centric approach to energy management, laying the foundation for a smarter, more resilient energy future. Now, let's see how this technology can benefit us. Firstly, consumers can expect reduced energy bills thanks to efficient energy use and reduced waste. Smart meters empower customers to monitor their energy consumption in real time, encouraging them to adopt energy-saving behaviors. By shedding light on energy usage patterns, These meters enable consumers to make informed choices about appliance usage, lighting, and thermostat settings, all of which contribute to lower energy bills. Secondly, the grid's reliability is significantly enhanced, minimizing outages and ensuring a consistent energy supply. Smart meters equipped with advanced communication capabilities can detect outages and notify the utility companies almost instantaneously. This rapid notification enables utilities to dispatch repair crews quickly, minimizing the duration of power outages and improving overall grid stability. Finally, there's a reduced carbon footprint due to the reduction in energy consumption and waste. As consumers become more aware of their energy usage patterns, they can make conscious efforts to reduce their impact on the environment. By shedding light on energy-intensive activities and their associated carbon emissions, smart meters encourage eco-friendly practices, contributing to a cleaner, more sustainable future. So there you have it, folks, the incredible potential of smart meters and data analytics in reshaping our energy landscape. As we continue to march towards a more sustainable and digitally advanced future, these technologies will play an increasingly pivotal role. Their ability to optimize energy distribution, reduce waste, and enhance grid resilience is nothing short of transformative. Now, let's see what you think about this. Drop in your comments to let us know. We'd love to hear your thoughts. And if you found this video helpful, don't forget to hit that like button and subscribe for more insightful tech content. Thanks for joining us today, and we'll see you in the next one. Until then, stay curious and keep exploring the exciting world of technology.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.